Question 12. Here are 6 graphs of straight lines. Graph A, B, C, D, E, and F. And match up each of the graphs A, B, C, D, E, and F to the equations in the table. So before we do that, we're going to probably use a bit of process elimination to determine which one's which. And y equals mx plus c is the general equation for a straight line. Okay, where c, the n number, is going to be the y-intercept. So in this case here, this is minus 2, so it would cut the axis at minus 2. So it could be graph f, but we'll have a look at that in a bit. And m determines the gradient, how steep the line is. So first of all, if the gradient is positive, you'll know that the line goes up like that, and if it's negative, it goes this way. So let's look at all the ones with a negative m, a negative gradient. So that's this one here, this one here, and this one here. Okay, there's only 3 luckily. Now, one of them has a positive 2 intercept, and the other 2 have minus 2 and minus 2 as their intercept, as their y-intercepts. So let's have a look at the graphs. There's only 3 graphs with negative gradients. That's A, C, and D. Which one's the odd one out with y-intercept of positive 2? There it is. So graph A must be this one here. Okay, as it has a negative gradient and a y-intercept of positive 2. Now the other 2, the only difference is the gradient of minus a half and a gradient of minus 2. So let's have a look at those graphs again. That one's done, so I'll just give that one a tick. Now, if I have a look at this one, 1 to the right, it goes 2 down. 1 to the right, it goes 2 down. So this one has a gradient of minus 2. And this one, 4 to the right, it goes 2 down. So that means 2 to the right, it must go 1 down. So 1 to the right, it must go half down. So this one must have a gradient of minus a half. So let's have a look. So one of them has a gradient of minus a half, which was D. And this one has a gradient of minus a 2, which was graph C. So far so good. So now we've got the other half, the other 3 to do. So once again, we're going to have a look at the intercept, see if there's any clues there. So that's positive 2, minus 2, and positive 2. So the one with minus 2 is going to be the one that we can put in now. So there's only, out of these 3, so graph F, graph E, and graph B, only graph F has a gradient of minus 2. So that one has got to be F. Now these 2 equations here, the only difference is one has a gradient of positive 2 and one has positive a half. So let's have a look at that. Now we've done F, let's take that. So this one here, 4 to the right, it goes 2 up. 2 to the right, it must go 1 up then. And 1 to the right, it must go half up. So this one must have a gradient of a half. And this one here, 1 to the right goes 2 up. So this one must have a gradient of 2. So hopefully one of them has a gradient of 2. Yes, it does. This one, E. And apparently the last one has a gradient of a half. I can't remember what I wrote. So the last one was graph B. And yes, it has a gradient of a half. So everything's okay. And a y-intercept of 2. So half here and plus 2. Perfect. So that was graph B. So we filled in all 6. It's not a good idea to scribble the whole graph out once you think you've done it, because you might want to come back and check your paper at the end. So question 12 is worth 3 marks, and let's have a quick look at what the mark scheme says. So, if you got all 6 of these correct, then you get all 3 marks for question 12. If you got 4 or 5 correct, you get 2 marks, and if you got 2 or 3 correct, you got 1 mark. If you only got 1 correct answer, then I'm afraid you don't get any marks. So question 12 is worth 3 marks, and you have to get all 6 of those in the correct places. And that's it.